Hi guys, today we will have application for, do you heard about COVID-19? Yes, we heard. This is a website, the official website for United Arab Emirates. If you go for any date, you give you the how many one infected, how many one recovered, and how many one in the critical situation, and how many one died, right? So day by day, okay? So every day I calculate this data and make daily data, right? I would like you to apply for April the central tendency measurement and the variation measurement, okay? So I copy this one and I open a new sheet by clicking plus, right? So when I come to here, I get the title for this variable, okay? Which is the date and the daily infected and the recovered, right? Okay. So, and then Control V. This is a mistake, common mistake about paste in Excel, right? Because over there, I'm using some mathematical formula, right? So I'm just make undo. I don't like this kind of paste. Right click, okay? Using the right click here, down the title, click and choose the second one. The second one just give you what? Give you exactly the values here, right? So I'll go back again to the daily data, right? And I would like to have the April, okay? So I have the title for each column, the name of the variable here, date, daily infected, and daily recovered, and daily date, right? So I'll go for the sheet, I open it, right? And Control V and write it as a value. Yes, you have a problem with the dates. I don't need the dates, right? I know this is April, right? So no need for this one because this formula should be as a date. So if you format this one as a date, it will accept it as a date, right? So I no need for the date. I start from 1st of April and end up with 30 of April, right? So I have 30 data. I have 30, April 30, April 30, right? So I know this, oh, sorry, I write this. So April 30. So I got 1 month data, right? Remember, 1 day of the April have nothing, right? Okay. So I would like to have the average or the mean for this one, right? This is the daily dead, okay? Daily, okay? So now, yes, I can make the descriptive statistics for all of these ones in one go. No need to do it one by one. How to do this one? I go for in data. Now you have data analysis activated in your computer. If you don't know how to activate it, right click here, choose customize. You have this window, go for add-ins, right? And then choose the toolbar and don't press OK, press go, please. When you press go, you will have this hidden packages. If you would like to use this one, just tick it and press OK. Now, if you go for insert or home or file, you will never see the data analysis, right? But if you go for data, yes, you can see the data analysis, right? So I'll go for data analysis. Now, how to find the descriptive analysis for this one? The value of the central tendency measurement and variation measurement, right? So for more than one variable in one go, yes. So I'll go for data, Okay. And I will have data analysis here activated already. I have descriptive statistics. I choose it and press OK. You're asking me which one you would like to. This is the old one. I shaded somewhere here. So make it blank. And now shade whatever you like to find the descriptive statistics for. I'm using daily infected, daily recovered, daily date. For this 1 month, I got it from my original data. My data in column, so I'll take column. If my data written in rows, I press rows. So I have it in column. If I have a title for each column in the first cell, like this one, I have to take the label. I would like to have the result of the descriptive statistics where this is the old one I take. So I make it blank and just click in empty space, only in one cell, right? And then what we'd like to do, I would like to make the summary statistics. And we will see what is the summary statistics give us. Yes, lucky I am. It takes hours to do this one, okay? So let's go and see what's going on. What do you have in the central tendency? What is the central tendency? The mean. I highlight it. Okay. What else? The mode. Okay. And what else? The median. So this yellow one are the central tendency measurements, right? Okay. Now, what is our variation measurement? We have the range. Okay. Range. I'll just change the highlight just to make it different. Okay. Blue. Okay, blues. Okay. And what else? Range and what? Standard deviation. Yes, standard deviation is one of the measurement of variation. Okay. Also the variance, which is the square of the standard deviation, also is a measurement of variation. And what else? Coefficient of variation. Do you remember this one? What is the coefficient of variation? The coefficient of variation, I'll just remind you by our lecture here. No, the other lecture. What is the coefficient of variation? Yes, here is the coefficient of variation. It's the standard deviation over the mean divided multiplied by 100, right? This is how to find it. It is not given in the Excel, right? But you can do it, right? You can do it. So it will be done by yourself. So I'm just shading this one the same color as the blue, which is indicating to the variation measurement. And I call this one coefficient of variation. Coefficient of variation. Okay, so how to do it for the first one, daily infected, this one? Okay, how to do it for this one? Press equal. You divided what? I just remind you again. You divided the standard deviation over the mean, right? Okay, so I'll go for the standard deviation. With the standard deviation, here it is. And make divide. And by what? By the mean, this one. Press enter. Okay, this should be percentage, right? If you just click here, it changed it into percentage, but roughly percentage, right? Okay, but I prefer to leave it as it is, right? Multiply by 100. Okay, so it will be what? Exactly 34.72, okay, percent. That's it. So it is better than clicking in the percentage, and we will round as a value, right? Once you have done this one, okay, if you just cut this one first, and paste it somewhere else. And if you drag this one here, what's he going to do? Yes, this is a text. This is why he gave you unreadable stuff. But this one, look at this one. This is a division of the standard deviation over the mean, right? Okay. So I can change this one into percentage to get this one back. So using the Excel, no need to calculate many times, right? You can drag down or drag right. You can calculate it, right? This one is 62.841%, right? And this one, it will be 78.4374%. So which one is bigger? The coefficient of variation of the date is bigger than the recovered, and bigger, sorry, the recovered is bigger, no, the date variation is bigger than, so this is the data of variation in the date is higher than the variation in the infected and the recovered, right? So the yellow one again is the central tendency measurement, mean, median, mode. The blue one are the measurement of dispersion or the variation, which is the range and the standard deviation. But you have one is not included here, which is called coefficient of variation. Once you know the mean, the standard deviation, and divided by the mean, you can get the coefficient of variation. The coefficient of variation is a percentage, right? Remember this one. Again, this is a rule, a formula how to find the coefficient of variation for the sample or for the population. The difference is the symbol. The notation for the standard deviation for the sample is S, for the population is sigma. The mean for the sample is X bar, the mean for the population is mu. Okay, so this is what I would like to tell you, how to use Excel to do whatever we have done the last lecture. Clear? The main point of coefficient of variation, it doesn't depend on the units. So I can compare two different things, weight and height. This is by centimeter, for example, and this is by grams. But I don't care. I'm caring about this one has a higher variation of this one or not. So when you divide it, the standard deviation by the mean, this is why the same unit or like the mean. So the unit will be cancelled out with the unit. So the coefficient of variation doesn't depend on the unit of the variable you are measuring. Be careful. Excel give you the central descriptive statistics for raw data or ungrouped data. But if you have grouped data, this is different issue. You have to know the formula and you calculate it by the mathematical formula in Excel. Clear? So Excel will help you finding everything for the raw data. Also, Minitab will help you straightforward. No need to make it. And also the Minitab will give you straightforward the distribution table. Okay, and we'll show this one after the midterm, inshallah. This is a COVID-19 data, daily data. It's accumulated. If you would like to have any data for any country, you just press on this one. Okay. They give you all the countries, but I deselected all of this one, and I'm looking for United Arab Emirates. So I'll go down here. Where is United Arab Emirates? Here it is. So I just take only United Arab Emirates. After this one, he will delete all countries except United Arab Emirates, right? And give you straightforward the percentage of death and the percentage of susceptible and infected. And this is the main point I'm looking for. This is the daily data, right? When you go for the data, I would like to show it as a table, right? I don't like to read it. So I'm right click here, right? and show as a table, he will give it to you down this one as a table, right? I go down here. Do you have your calculator?
Yes.
Okay,
Yes,
let's
Doctor,
start.
yes.
Let's start for only 1 week, just not to take too much time, right? We'll go from Sunday to Saturday. So we will have the average for 1 week, right? So press mode, go for statistics, go for variance. You have one column, right?
أيوة دكتور.
Type 7, press equal to go to the next row. Type 8, press equal. Write the second 8, press equal. Write the third 8, etc. until you finish as you like. If you go for more, that's okay. Let's go for 22nd of February, right? Once you finish, let me know.
مسرودة سرد بدون تكرار. بكل بساطة بندوس on، بنروح على المود ونختار stat number 3، وبعدين نروح على variance أو variable هي number 1، وبعدين ندخل البيانات بتاعتنا اللي هي 10، وبعدين عشان ندخل الرقم اللي بعده لازم ندوس يساوي
equal،
وبعدين 15 يساوي الرقم اللي بعده 17، بعدين يساوي 11، بعدين يساوي، وبعدين 5، بعدين يساوي، آخر واحد 8، بعدين يساوي. بعد ما بدخل البيانات بدوس AC عشان يعمل ستور أو يخزن البيانات، وبعدين شيفت واحد، وهنلاحظ إن على الواحد دي في كلمة ستات، عشان كده دوس شيفت واحد. هروح برضو لنفس اللي أنا دوست عليه لما دخلت بيانات غير ممول اللي هو الفاريبل أو الفاريبلز رقم 4. لو عايز المين اللي هو اكس بار بدوس نمبر 2، بدوس يساوي، يبقى المين هيطلع بكام؟ ب 11. لو عايز الستاندرد ديفيشن او الانحراف المعياري برضه بدوس شيفت واحد مره ثانيه، وادوس على الفارينس، وادوس على اس اكس اللي هو الانحراف المعياري اللي هو رقم 4، بدوس 4 وبعدين بدوس يساوي، يطلع 4.4271. لو عايز التباين كل اللي انا بعمله ان انا بدوس على المفتاح اللي فيه اكس تربيع، لان انا عارف مربع الانحراف المعياري هو تباين. بدوس على التربيع بعدين يساوي، يطلع الفارينس 19.6.
Now let's go for the third type of measurement, which is the measurement of position. Position from where? Position from standard stuff. Which is a standard stuff? The mean.
Thank you, Doctor.
Now we will go for the measurement of position. What does it mean, position? Position to the right or to the left for the means, right? So once you have your data and you grab the histogram, if your data is symmetric, it means the mean and the median, the mode are the same value. So these z-scores give you where is your value far away from the mean. So how to calculate the z-scores? You get the value, so you have to know the mean, understand the deviation for your data, and you substitute in this formula using the notation of the sample if your data is a sample data, but you're using the notation for the population if your data is for the population. Once you substitute, you get a value. What does it mean, this value? It means the position of this value, which is 30, is higher than the relative position of the history class, right? Which is to be to the right. This is why it is higher than the mean. But in the next example, we have two tests, and we would like to see which test is higher than the other, right? Okay, for these two values, 38 and 94. So we should have the mean and the standard deviation for the first test, as well as the mean and the standard deviation for the second one. Okay, so substitute in test A for the value 38, you get the position of the 38. For 94, you go for the position of 94, it will be minus 0.6. Be very careful with the negative values, because minus 0.4 is higher than the minus 0.6. This is why the score for test A is relatively higher than the score of test B. Clear? Because the 38, even if it is less than 94, but it's closer than the mean of test A, right? This is how to use the z-scores to compare between two different data, quantitative data. Let's go for the second measurement of position, which is called percentile. Percentile coming from the percentage. So if you remember, when we go for the cumulative frequency Ogive distribution, which is, if you remember this one, I'll just show you. Yeah, this is what I would like to know. If you remember, this is the Ogive, right? Or the cumulative relative polygon as well. The difference is the line here. It will be curved if you are going for the Ogive. But the main point here, your data is not represented by the frequency, is represented by the percentage, right? So this is exactly to know where is your data if the value in the 40%, you just go for the cumulative relative polygon, or you go for the Ogive, which I prefer, and go down to know this value 119.5 or roughly will be the value. If this person get this value, it will be in the 40% position if you sort your data from 0% to 100%. This is, it comes using the cumulative frequency, and then you get the relative cumulative frequency, which is the percentage, cumulative percentage. What about if you know the value and you would like to know this value represent what? Where is its position from the 100%? You just go up, hit the cumulative relative polygon or the Ogive, and go horizontally until you reach the percentage of this value. Okay, this is very important use for the cumulative relative polygon or the use of the Ogive. Now we have very special percentage, what we call it 25%, and we call this one the first quadrant, and 50%. Where is the position of the 50% of this data? Okay, what we call it second quadrant, 50% of the data. I heard this before. What is this one? I call it the median. Yes, the value in the middle after sorting my data, I call it before the median. And I remember when I have odd data, I have the median in the middle and will be one of the value. But if I have even number of data, I have two values in the middle. How to get the median from this one? I add them together and divide it by 2. So I had the 50% before belonging to the median. So the second quadrant is the median. And the third position is the 75% of the data, what should I call it, the third quadrant, right? All of this percentage lying between the minimum value and the maximum value, okay? How to find the percentile? You just write the number of values. Below this value, you would like to find the percentage before, right? If I would like to find the percentile for 8, I will take the 6. And remember, when you go for percentile or the median, you have to sort your data from the lowest to the largest, okay? And add half and divide it by the total number of values, or the number of data, which is, there are 10 data here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is not a sum, this is a number of data. This gives you the percentile. So this value, which is 8, lying in the 65 percentile. It means before this one, there is 65% of the data. After this one, there is 35% of this data. Okay, this is what does it mean, percentile? And we said, again, we link this one to what? To the cumulative relative polygon or to the ogive. So again, if you know the percentage of your value of, you would like to find the value at the 40%, you go straight to hit the cumulative relative polygon or the ogive and go down to know the value at this position, right? Vice versa, if you have a value, you go up to hit the cumulative relative polygon or the ogive, and you go horizontally to hit the position of this one. So if you know the position, you can find the value. If you know the value, you can know the position or the percentile. Okay, let's go for this one. If he's asking you to find the first quadrant, which is denoted by Q1, the second quadrant Q2, and I know Q2 is the median, and Q3 is a 75%. And I have this one. So again, I have to sort or arrange the data from the smallest to the largest. And the median, it means one in the middle. How many ones I have? 1, 2, 3, 4, 5, 6, 7, 8. So I have even number of data. So the median will not be one of them. So if the middle, I have two values, 13 and 15. So the median will be the average of these two. 13 plus 15 divided by 2 give you 14. So I know the median is 14, right? How to find Q3? Okay, so you go for the 75%. Q1 after 25%. I have 8 data, right? So the 8 data, 25% of them is 2, right? So the Q1 will be lying here, right? But as I said again, I have an even number of data, so the Q1 will not be one of my data, but it's lying here between the second and the third values after arranging them from the smallest to the largest. How I can get it? Q1, I add 6 plus 12 will be 18, divided by 2 give me 9. So I find Q2 and find Q1. Let's go for Q3. Q3, it means 75%. What does it mean, 75%? 75% of 8, it will be 6. So 1, 2, 3, 4, 5, 6. So my Q3 will lying here, right? So how I find it? It's lying between 18 and 22. So I add 18 to the 22 and divided the result by 2. So this will be my Q3. There is something called interquartile. This interquartile exactly like the range between Q3 and Q1, right? So if you subtract Q3 from Q1, I get something called interquartile range. Okay, let's go to summarize all of this one. A summary of position measures. We start with the z-scores, which give us where is the value lying. It is less than the mean or greater than the mean. To the right to the mean or to the left to the mean when I have a graph for my data, histogram or polygon or something. Percentile is exactly the position value when I'm ranking my values from 0% to 100%, which I call it cumulative relative frequency. Okay. Decile it is this one from the percentage. This is 1 out of 10. So I don't care about this one. But the most important one is the quartile. The quartile, I have three quartiles. The first quartile, it means the position after 25% of my data. The second quartile, which is after 50% of my data, which is exactly like the median. And the third quartile is the value after 75, exactly at the 75% of my data. Okay, so in the Q1, 25% of the data before this Q1 and 75% after. In the median, 50-50, 50% before the median, 50% after the median. Q3, 75% before this value and 25% after this value. Why I'm doing so? We will see how to graph this one in a graph, and we'll see, we call it the box plot graph. Also, if you have outliers or non-expected value, this will affect the interquartile, because the interquartile depends on the Q3 and Q1, right? So when you arranging your data and you have outliers, your interquartile will be different, like as you see here, right? This is how we know the mean affected by the outliers, the median affected by the outliers, right? What else? The range affected by the outliers, and the interquartile arranged by this one. But the most affected one by the outlier is the mean, okay? Because you have the sum in this case. Clear? Let's go for how to graph this Q1, Q2, Q3, and the minimum value and the maximum value. This is what we call it 5 elements, 5 number summary, okay, which I call it box plots. Why I call it box plots? This is exactly like a box. Here it is. The start of this box is the minimum value. The end of this box is the maximum value. In between, you have the box. The start edge of the box is the first quartile. The second line edge of the box is the median. The third edge and the closing the box is the third quartile. This is what we call it box plot. So in this data, first you have to sort them from the smallest to the largest. You are unlucky because this is even data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you divided 10 by 50% of the 10 is 5. You don't have this median will lie after the 5, the value number 5 and the number 6. So how to get the median? You add these two together and divide it by 2. This is the most difficult when you have even number of data. So the median will not be one of your variable. The first quartile will be one of your value. Why it is? Because it's 25%. The 25%, it means what? Out of what? Out of 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 25% of the 10 is 2.5, right? 2.5, it means I have no values ranked by 2.5, but it ranked by the first, the second, the third, the fourth. So my first quartile will be the next integer for the value of the position. So it is the third one. So my first quartile will be the third one, which is 47. What about the Q3? 75% of the 10 is exactly 7.5. So I'll go 1, 2, 3, 4, 5, 6, 7. I don't have 7.5 position, but I will take the next one, which is number 8. So the third quartile is 164. Now, how to graph the box plots? I have a line, and I put the beginning. Okay, I put the minimum value, which is 30, and at the end, the maximum value, 296. So I have to scale this line up to my value. So I scale it from 0 to 300 because I have 296. And I go for the 30 here and I put the minimum. At 47, I start to open the box, the first edge. At 83.5, I make the second edge of the box. At 164, I close the box. Okay? This is my box plot. What is the point of graphing this one? Yes, the median is not in the middle of the box, which means my data is skewed. Skewed to the right or skewed to the left? Skewed to the right. Okay? This is exactly like the tail when we have skewed to the right. This is how to graph the 5-number summary graph, or they call it box plot. So the box plot is the same as the 5-number summary. Okay? Now let's go. If you have two data, two variable, and these two variable are ratio variable. Okay, so you can graph the box plot for the first one. I get the minimum, I get the first quartile, second quartile, the third quartile, and the maximum, and I have the box plot. And I have the box plot for this one. But remember here, this box plot is wider than this one. So it means my data here is more vary from this data here, right? This is the main point of using the box plot, but I cannot graph the box plot until I have the first quadrant and the second quadrant, which is the median, and the third quadrant for each data, right? This is the main point. So you say this data larger than the variation of the other one, depending on what? Depending on the width of the box plot. Is it clear? So the real cheese data has a wider box than the cheese substitute. This is why you said the variation or spread of the distribution of the real cheese data is larger than the variation of distribution of the cheese substitute data. This is very important to compare, and later on we'll see how to do this one using MATLAB and using Excel if we could do. Be careful, the first quadrant is the median of the median, right? So you take the first half of your data and take the median for them. It will be the first quadrant. The third quadrant is the median of the other half of your data.
دكتور
تفضل.
بس في طالب عنده فصل النت